Okay, so today what we will do, we will discuss like consolidate the problem, whatever we discussed earlier means similar kind of problems. Okay, so I hope you can try to solve and see the answer also. We will discuss like that. Okay, please mute the sounds. Okay, so we will start with this problem. So this can be solved nearly, I think, more than 50 problems by this week. So in each session, normally we used to follow our assignments. Okay, but today what I did, these last two class means today's class and next week also, we will wind up the problems. Okay, how much like from the efficiency to all that till now whatever you covered, all that. So first problem today, here we are going to discuss a heat pump operating in on a Carnot cycle pump heat from the reservoir at 300 Kelvin to a reservoir at 600 Kelvin. You have to find the coefficient of performance here. Yeah, so please try to find it, then we will solve and share here. Okay.
I got the answer actually.
Which you know? Okay, let's try. So how to solve it? COP you can calculate T1 divided by T1 minus T2. You can write it as 600 divided by, you will get 300, then answer will be 2. So here T1 greater than T2, that's the case. Okay. Now we will go to the next one. The question is, an industrial heat pump operates between the temperature of 23 degrees Celsius and minus 15 degrees Celsius. The rate of heat addition and heat rejection are 70 watt and 90 watt respectively. Find the COP of the heat pump. So here power is given, that which means Q value is given. You have to find the COP.
And 4.5.
4.5. So for solving that, here you can see the power values are given, heat rate. So how to find its COP from that? COP will be Q, we can call it as QL and this is QN, then it will be QN minus QN divided by so it will be 90 divided by 90 minus 70, so the answer will be 90 divided by 20, it will be 4.5. Now we'll go to the next problem. The ratio of minimum and maximum temperature in a Carnot cycle is 0.6. If an heat pump is operated between the same temperature limit, then what is the COP value? So here this TL by TN ratio is given. Okay, now you have to find the COP of heat pump. So it will be Tn divided by Tn minus TL. Okay, so take Tn outside, then how much you will get? 1 divided by 1 minus TL divided by Tn you will get. So that you can write it as 1 minus 0.6. So here you will get the 1 minus 1 divided by 0.4, then that will be the answer. Okay.
And everything.
problem is a reversible Carnot cycle refrigerator maintain the temperature of minus 5 degrees Celsius. Okay, the ambient temperature is 35 degrees Celsius. If the heat gained by the refrigerator at a continuous rate is 2.5 kilojoule per second, then find the power, that's in watts, required to pump the heat continuously. So for solving this problem, first you have to change the temperature into Kelvin and use the COP equation for that and try to solve it. Okay.
Then I'm getting 0.32.
How much?
0.32.
So TL temperature you can write minus 5 degrees Celsius. It will be minus 5 plus 273. So the answer will be 268 Kelvin. Similarly, Tn you can write 35 degrees Celsius. It will be 308 Kelvin. Okay. Now what are the given rate is given, so that it will be 2.5 kilojoule per second. Now we have to calculate the power. Okay, so COP you can write this RC by P in. Okay, that we can write first equation. Similarly, COP in the ideal case you can write TL divided by Tn minus TL. It will be 268 divided by 308 minus 268. So it will be 6.7. Okay. Now this COP maximum will be equal to this COP value. Okay, that will be 6.7. Now this you can put it in the equation 1. So you will get the answer 6.7 is equal to 2.5 divided by P in. From there you can calculate the P in value. 2.5 divided by 6.7. So it will be 0.3 kilowatt. You can convert it into 0.373 to get 373 watt. So unit is very important in these problems. Okay, you in exams also you will get like options. You have to select the appropriate one. So unit also important. Kilowatt, watt, or other conversion also you should know it very well.
Okay.
Okay, now we'll go to the next problem. Next problem is a refrigerator freeze water at 0 degrees Celsius into 10 kilogram ice at 0 degrees Celsius in time interval of 30 minutes. Assume the room temperature is to be 22 degrees Celsius. Calculate the minimum amount of power needed to make 10 kilogram ice.
And we got 268.8.
Yes, you're saying about power.
Yes, ma'am.
Try 1 second. You have to use this formula like Q is equal to ml. Okay, then you will get the Q value. From that Q value, you can know the COP formula. It will be Q2 divided by W, that is equal to T2 T1 minus T2. Use these formulas and solve. Okay.
And 0.15.
0.15. Yes.
You may get questions like these in the NPTEL exam. Will we get questions like these in NPTEL exam, final exam?
Yeah, we will get. There will be like optional questions like theory questions also, what you are seeing in assignment. Similarly, problems also. And in that multiple answer will be correct. Sometimes one answer will be correct.
Like gate model.
When is your exam?
It's on 29th this month. 29th. 29.
29. Okay, so you have enough time. You are from?
I am from Andhra Pradesh. Andhra Pradesh.
Which institute?
IIT Tirupati.
So this is the course like your coursework or?
Yes, ma'am. This is my pre-elective. Yes, ma'am.
Which stream? Which engineering?
Mechanical.
So you mechanical also can take this as elective.
Yes, ma'am.
Okay, let me complete this and go to the next one. So Q will be ml, so it will be 10 times 80 times 4.2 divided by 10 to the power minus 3, so it will be in joule per kilogram. Here also 10 kilogram. So you will get the Q value from here, and after that we know that this COP formula, that will be Q2 divided by W, that you can write as T2 by T1 minus T2. So from the W will be Q2 times T1 minus T2 divided by T2. So substitute those values. So 80 times 4.2 divided by 10 to the power minus 3 times 295 minus 273 divided by 273. So then from there you will get the value of power. It will be W divided by 30 times 60. So it will be 80 times 4.2 times 22 divided by 10 to the power minus 3 times 273 times 30 times 60. Then you will get the answer 0.150 times 10 to the power 3. So it will be 150 watt. Now you please go to the next problem. A Carnot engine have an efficiency of eta is equal to 1 over 10 as the heat engine is used as a refrigerator. If work done on the system is 10 joule and the amount of energy absorbed at low temperature is. You have to find the energy.
And I'm getting 100 joules. 100. Yes, ma'am.
From that you will get the T2 values, T2 by T1 values. You have to substitute that in the work formula. Is it like that you solve? You have to compare the formula like heat engine as well as refrigerator. Okay. For a heat engine, the efficiency formula 1 minus T2 divided by T1. Okay. Refrigerator case, you can write COP, coefficient of performance, W, Q2 divided by W. Then that you can write as Q2 divided by Q1 minus Q2. From here you will get the ratio of Q2 by T1. Substitute that here. This formula you can rewrite Q2 divided by T1 minus Q2. So take T2 outside, then substitute that value, then solve it.
Ma'am, now I got 90.
Nice, thanks. So you have to solve this. So here from this you will get the value Q2 divided by W, that will be 9, and from that the W is the work done, it is given in the problem. So 9 times 10, it will be 90 joules. So that will be the answer for this question. Now you go to the next problem. A refrigerator A works between minus 10 degrees Celsius and 27 degrees Celsius, while refrigerator B works between minus 20 degrees Celsius and 17 degrees Celsius, both removing 2000 joule from the freezer. Which of the two is better refrigerator? So you have to compare the refrigerator. You can compare through calculating the work. So do the work formula here, like no, not work, like coefficient of performance. So do that, you will get the exact value. Means you can compare those two refrigerator. Temperatures are given. So convert each temperature into Kelvin and do that.
And B is better. Refrigerator B is better.
B is better. Which coefficient of performance is higher?
A.
Then A will be better, right? Which refrigerator performance is better? That will be the good refrigerator, right?
Yes, ma'am.
Okay.
Right,
Obviously,
ma'am.
means refrigerator A will be the correct one. So here, the both refrigerators are removing 2000 joules so from the freezer, which means we no need to compare that part, so we can compare only with the temperature. So coefficient of performance of the first refrigerator, it will be T2 divided by T1 minus T2. So it is given this minus 10 degrees Celsius and 27 degrees Celsius, so you can write it 263 divided by 300 minus 263. So it will be 263 divided by 37. You will get the answer 7.1. Similarly, coefficient of performance of B you can calculate using same formula, T2 divided by T1 minus T2. So it will be 353 divided by 37. So the answer will be 6.83. So from the COP of A will be greater than COP of B. Okay, now you go to the next problem. The question is a Carnot heat engine has efficiency of 10 percentage. If the same engine is worked backward is obtained a refrigerator, then find the coefficient of performance.
And 9.
Yeah, done. So did you attend the interactive session which you had earlier?
What, ma'am?
There were one interactive session, right? So
Interaction session.
it was there one interactive session.
With the teaching professors.
Yes, yes.
Yeah, yes, ma'am. That was happened 2 weeks back at 3 p.m.
Yes, yes. You attended?
No, ma'am. At the time I am having lab. That's happened on Tuesday.
Okay. So,
So,
like, you are able to follow the classes, right? Like,
yeah, yes, ma'am.
so are you using that NPTEL for like asking the
I,
doubts and all?
I answered some doubts. They replied no.
Did you get the reply?
Yeah, yes, ma'am.
So this will be like for your course, this will be also considered as a one subject, right?
Yes, ma'am. Actually, we are having energy conservation as a course in my fourth year.
Okay.
Now I am in third year.
So now you are attending already, right?
Yes, ma'am. So it will be next year.
So here the efficiency is given, so that will be, you can write as 1 minus T2 divided by T1 times its percentage. Okay, so it will be 10 percentage. Okay, now coefficient of performance, you can write T2 divided by T1 minus T2. So that 1 minus, it will be 1 over 10. Then from there you will get T2 divided by T1 will be 9 over 10. That T1 divided by T2 will be 10 over 9. So this you can take at first equation. Then here you can write it as 1 divided by T1 divided by T2 minus 1. So that will be 1 divided by 10 over 9 minus 1. So it will be 1 over 9. So you will get the answer 9. Now we can go to the next problem. How many kilogram of water at, sorry, it will be 0 degrees Celsius. Okay. 0 degrees Celsius can freezer with a coefficient of performance 5 make into ice cube at 0 degrees Celsius with a work input of 3.5 megajoule. Okay.
getting 53.96 kg.
How much?
53.96 kg. Then 48.87.
How much?
48.87.
Okay, once again let's check. How you calculated it? You have to find Q is equal to ML formula. Okay, from there you have to calculate, you will get the Q value, substitute that Q value for the work done equation. Then you will get the answer.
Madam, hello.
Yeah?
Madam, recently I joined, madam. Just please, because of the late coming to home. Kindly explain the problem once again, madam. Please.
Which one?
Kindly, because recently joined only, madam, in the classes.
Okay, do you want to
Hello.
just briefly go through all the
Yes.
problems?
No. Just please. 10 minutes only. That only the. Please explain this the formulas. This formulas how to approach.
Okay, this
Approach.
problem. Yes. So here actually you have to first calculate the Q value, heat energy value. So it will be ML. Okay. So mass is given
This is
already.
thermal energy, madam.
Yes,
This
yes.
is TES.
Hmm.
Okay.
Okay, then latent heat is given. So M you will get the Q value. From after that, you can get that coefficient of performance will be Q2 divided by W. Similarly, you can write it as T2 divided by T1 minus T2, right? So from there, using this set, you have to calculate the work done. So from here, this work done only in the question they asked. So work done will be, this Q will be your Q2 value. So Q2 times T1 minus T2 divided by T2. Just substitute this, you will get the answer.
The melting point, why is the temperature T2, madam?
How
Only one
much?
temperature is given. The only one temperature is given. When the external temperature, I think T1, T2, both temperatures go, no?
Yes,
Temperature, only one
another one will be
temperature.
0 degrees Celsius, right? This
0 degrees
this
Celsius. Okay. Sir, that's in there. Sir, T1 is 0 degree, huh? Sorry, good.
so
Thanks, madam.
T1 will be 20 and T2 will be 0.
0, okay. Sorry, right.
So here you have to multiply like this, then it will be in per hour. So per hour you have to convert it into seconds. So it will be 3600. Okay. Then this value, this Q value, you have to substitute here. Then your answer will be 2 times 80 times 4.2 divided by 10 to the power minus 3 times 3600 times T1 minus T2. So 293 minus 273 divided by 273. So final answer you have to get it then. Substitute all this value, then you will get the final answer. It will be in watt because we have already.
No, this is the latent heat unit is 80 calories per gram,
Yes.
but the given M equal to kg per. It is taken care of, madam. The problem.
What?
It is rate mass flow M equal to 2 kg per hour. This kg.
Yes, kilogram per hour, right?
You take it, madam. Okay, 10 to the power minus 3. It shows that one, huh? You taken care of, madam. In the
Yes.
problem, you taken care of this one.
That unit conversion, right? We have to calorie to gram to joule per kilogram.
Yes. Okay. That is 4.2. Okay,
Then
right,
only we
madam.
can get it in the joules per second. Otherwise, watt. For we need watt, right? Because your
Yes.
problems
What is
always
joule per second? Correct.
in your exam also you'll get means standard units. So you have to know this conversion definitely.
Okay, right, madam. Thanks.
Because latent heat always it will give in calorie per gram, but you have to always convert it into 4.2 divided by 10 to the power minus 3. Then you can convert into joule per kilogram that. Okay.
Okay, right.
So how much answer you are getting? You will get the answer 13.68. So listen, today's class like we are your course got over, so we are just consolidating all the problem kinds. So today I selected only the efficiency problem you know already because formulas are already straightforward. So coefficient of performance, after that power, then from using those two and latent heat of ice, whatever the compound, and sometime you will get the problems like combination of two refrigerator plus means Carnot plus heat pump, refrigerator plus heat pump, like that several combinations also you will get. I think in week 9 class or something I solved such kind of problem. That is very important problem because same kind of problem is given in your assignment also. So please go through the assignment carefully. Similar kind of problems only you will get the exam also. Such kind of problems I solved already in our all these week classes. So please go through it. Then only you can easily get the mark in your course for this NPTEL course. Okay. Next week, one more class will be there. That will be the winding kind of class for this course. So please go through the already given assignments and submit this week assignment also. Last assignment also given. So please go through that also and go through the theory problems very well. Like what's are taught in the theory class related to theory problems will be there. So those are equal marks, theory and as well as problems. Theory you can solve it easily. That's why I'm not more discussing theory problems, but you have to go for the numerical problems also. So for numerical problem, it will be mainly it will be straightforward problems, but you have to like know the formulas perfectly. So be uh, like try to write all the formulas together. Like if you want to go for the COP, you have to know about the formula with temperature, formula with heat, all the things. Then it will be easy. Sometimes you have to like in this see here ratio is asking, so you have to connect those two formulas together. Some cases you have to do, you should know. See here, COP formulas are two kind of formulas are here. One is this RC by P, similarly the normal formula with respect to the temperature. So you have to get sometime both formulas, so you should know all the formulas for a particular problem. Okay, so we will meet the next class. So today here I'm ending all the classes. You can get I think all these classes and solution through the
No,
link.
the RC, madam.
Hmm?
Madam, one small doubt, madam. Please, that COP is equal to RC by P input. No,
Yes.
that is for me. It is new. Please explain, madam. That point.
Yeah.
COP is equal to RC divided by P input.
P input.
That RC
Actually,
means,
RC means this value,
or
the rate, continuous rate of the
what is that RC?
refrigerator. Here.
Please, madam, what is RC? That is
It's written
2.5 kilos. That is
it is a
continuous rate.
heat
That is
rate
gained by the
actually.
refrigerator continuous rate. Heat rate.
Yeah.
Heat rate. Oh, madam, heat rate. Right.
Yes. Please
Nice.
go. I think you will get all the class. class link through your NPTEL platform. Okay. So please go through it. If you have any doubt on the class session, these problems also you can ask in the next session. Okay. No issue.
Okay, thanks, sir.
Yeah, you will
Thanks.
get all the link, I think, because I can see the link in the NPTEL forum, so you will also get it. Okay.
Okay, right.
Yeah.
Okay, okay.
Okay. See you next class then.
Right.